Hey everyone, welcome to Chapter 4 of the guidebook. The purpose of this chapter is to introduce you to CAD assemblies. CAD assemblies are the deliberate collection of parts arranged in a particular way to create a product. For example, the ET66 calculator that you see in Chapter 4 is a collection of buttons, LCD screens, a top cover, a bottom cover, a battery door, a battery. All of these parts are separate parts in the CAD system, but in an assembly, they are gathered together and arranged in a purposeful way. And in this chapter, you're going to learn how to make assemblies. Now, to put this into context with the other things that have been going on, in the previous chapter, Chapter 3, you focused on creating CAD parts. You're still going to create some CAD parts in Chapter 4 as a way of practicing and continuing to develop skill. But in Chapter 4, you're going to be introduced to the idea of taking those separate files that were made in the CAD system and bringing them together into a new type of file called the assembly file. In fact, whenever you create a new part in SOLIDWORKS, you basically have three options. You can create a part, you can create an assembly, or you can create a drawing. This chapter is about creating drawings. This chapter is about creating assemblies. Now, in this chapter, there are a few things you should focus on trying to learn while you're reading. Item number 1 is the notion and the relationship between a degree of freedom and an assembly mate. And when we say mate, what we mean is the mating of two parts together. So let's just talk about this for a split second. Take, for example, this piston head. Okay, this piston head is from a 1964 Volvo that I used to have, rebuilt the engine, and this is the piston head out of it. This part, and every object, by the way, has 6 degrees of freedom associated with it. That is that the product can translate in the X direction, or in the Y direction, or in the Z direction. Those are 3 degrees of freedom. And then it can also rotate in the X direction. That's another degree of freedom. Or rotate in the Y direction. That's another degree of freedom. Or it can rotate in the Z direction. That's another degree of freedom. So there are 6 degrees of freedom. And whenever we're working on CAD assemblies, we're working to reduce the degrees of freedom so that the parts become constrained to each other. So for example, if I wanted to, in a CAD model, reduce some degrees of freedom for this piston, I would say to myself, well, I'm going to set the piston on the table. And as I set the piston on the table, one of the things I would do here would be that I would mate this surface to this surface. And that would be an assembly mate. Now, it's important to know that when we do an assembly mate like that, more than 1 degree of freedom might be reduced. So, for example, when I have mated this surface to this surface, no longer is Z translation allowed. Z translation is fixed because this face and this face have to be together. Now, I can still translate in X and still translate in Y. But there are 2 other degrees of freedom that are reduced with that single assembly mate. I no longer can rotate X in the X degree of freedom, because if I do that, then I break the constraint that this face has to be matching on this face. And I can no longer allow rotation in about the Y-axis, because again, I need this face to match up to this face. So when I say that I want this face to mate with this face, I have just reduced 3 degrees of freedom. Now I have just 3 more that need to be constrained. I need to constrain the X, need to constrain the Y, and I need to constrain the rotation about Z. This chapter will introduce you to degrees of freedom, the notion of degrees of freedom, and show how they relate to assembly mates. That's just critical item number 1 that you should walk away with from reading the chapter. The second thing that you should walk away with from reading the chapter is the notion of a strategy for producing a CAD assembly. So we had a strategy for creating CAD parts, where we thought about what do we want to create by adding material? What do we want to create by subtracting material? Is there any symmetry? What am I going to want to change later? Where should I place the origin? All of these wonderful kinds of questions. When we're creating a CAD assembly, a similar situation is occurring. We need to ask ourselves some thoughtful questions. And as we do ask ourselves those thoughtful questions, we are going to produce a better CAD assembly. Now, what I'm doing here is looking at the chapter, and I'm going to find the section where we talk about developing the assembly strategy. That is section 4.13. And here there are some key questions we're going to ask ourselves. What will the base part be? Now, what does this mean? This means that when we're assembling, for example, the ET66 calculator, the base part will be one of the main parts onto which most other parts will be assembled. So, for example, a button would not be a base part. We're not going to assemble everything to the button, but we might assemble everything to the back cover or the front cover. And so we got to decide, what is our base part going to be? The next step in developing an assembly strategy is we need to ask ourselves if there will be any subassemblies. And if there are going to be subassemblies, what are they going to be? Now, a subassembly is a collection of a few parts that will always stay together in the main assembly, and it may be easier to create that subassembly first and then put it into the overall assembly. That's another thing we need to think about as we're developing our strategy for assembly. All right, the next thing then is we need to ask ourselves if there is a design reason to leave parts unconstrained. So the goal is actually not to reduce all degrees of freedom, but to reduce the degrees of freedom that are consistent with our design thinking. So for example, I might have a shaft that goes through a bushing or a bearing, and I might want that shaft to continue to rotate in the model. And so I need to think about, what do I want my model to do? And if there are degrees of freedom that need to be left free, I need to think about which ones to leave free. All right, then if we keep going on here, looking at the other things that need to be done when we're creating our assembly strategy, we should ask ourselves, what will the general assembly order be? And it's typical to have a general assembly order be the same order that you would actually assemble something in real life on a manufacturing line. So in that case, it's valuable to be thinking about how actual parts go together. Now you'll find in the support videos for this chapter, I have taken the ET66 calculator, the physical calculator, taken it apart and put it back together so that you could see how all those parts are supposed to go together. All right, next question. There's two more questions we ask ourselves when we're developing our assembly CAD strategy. We want to ask ourselves, what reference geometry will be needed to complete the geometry? To complete the assembly? Will I need, for example, to create a plane somewhere or an axis, a critical axis that things get assembled to? If so, I've got to create that reference geometry. And then also, the last thing we want to ask ourselves is, in our assembly strategy, what parts are going to come from existing databases? So for example, I might find a database of O-rings, or a database of screws or bolts, or a database of, I don't know, what else, common parts like that. And I may choose to have some of those parts come directly from existing databases. And knowing that before I begin my assembly is a good thing to do. Okay, so that was the second thing we needed to learn, was the idea of a strategy for creating the assembly. And then the third and last thing you should walk away with understanding from this chapter is the notion of new evaluation tools that are available for assemblies that were not available for parts. Okay, so we know when we were making parts, we could measure, we could check the mass properties and other things like this. We can still do this in assemblies. We can make measurements, we can check mass properties, but there's a new evaluation tool that's very important, and it's called interference analysis. And what's going on with the interference analysis is we will check to see if we put two parts in the same place, like occupying the same volume. And if there is any part of part 1 that's occupying the same the same volume as part 2, the interference analysis will tell us that. Now, this is critically important because in a real life setting, when we manufacture these parts, if we try to put them together, they cannot occupy the same space in most cases. And so we want to do an analysis in the CAD system to check that. Okay, so that covers the basics of what's going on in Chapter 4 of the guidebook. You're going to learn about mates and how they relate to degrees of freedom. You're going to learn about CAD strategies for assemblies and the questions you should be asking yourself as you are creating a new assembly. And the third thing then is you're going to access new evaluation tools designed to take advantage of the benefits of having an assembly in a CAD system, where we get to look at the interference between the parts in the system. Okay, that's it. I wish you the best as you read through the chapter and work on the exercises.